Our next speaker is Belinda Pearce. Belinda runs a Do It With Dung from the Mountains to the Murray Dung Beetle Project, which is hosted by the Kiewa Catchment Landcare Group. The project utilises landcare facilitators and their groups to find interested farmers across the northeast region. Prior to her involvement with landcare, Belinda worked for the Lucyvale Better Beef Group, managing various dung beetle projects. Belinda will outline current soil health projects that involve worms and dung beetles. Belinda.
Hello. Now, you've all been sitting there rather passively. For this one, I'm going to be asking you some questions, so pay attention. Okay, we've got 15 minutes, 5 minutes for each subject. The first one, we're going to have a look at our Do It With Dung project, dung beetle monitoring results. Got a few people I can see that have been monitors. Then we're going to have a look at our Aparectodea, is that the correct pronunciation? Yeah, that's good, Pauline? A longer project, also known as the longworm or the black-headed worm. Then to finish up, and this is where there'll be questions and things to think about, dung beetles and pasture productivity. We'll be looking at some long-term research results. I also should mention the first two projects have been funded by Caring for Our Country. The first one is now finished and the second one is happening now, and it's a community action grant. Yeah. Okay, so our survey, it was the largest dung beetle monitoring program ever undertaken in southeastern Australia. So it was the largest in terms of the number of people monitoring, the size of the project and the length of time. We set traps. We had over 80 farmers across northeast Victoria and Kiewa Shire in New South Wales, setting traps every fortnightly and reporting on their results. We started with the bushfires in February 2009 and finished at the end of May. So our results, what did we find? Oh, there's the trap, very, very highly technical piece of equipment. And the next one, that's our lure for the dung beetles. So they were set, and here's a trap result from 28th of February. Now, who can tell me what species what's in that trap? Taurus fulvus is what it is. They're our small little summer beetles, obviously summer. The brown ones are fulvus and the black ones are Taurus. We found a great abundance of those two species across the northeast. So that's one trap. So one dung pad caught all those beetles. This is what species? Bison, well done. They're a winter beetle, but they're a little bit slow on the ground at the moment. So this I think there's 135 beetles, and it came from Marg. Is it Marg? Falconer's property out at Meadow Creek. So, moving on. What's the first thing you notice about those trapping results? What's special about those numbers? Introduced species, we caught 46,384 introduced dung beetles. How many native beetles? So that's about 1%. So 1% of our trap catches were native beetles. So when the CSIRO introduced dung beetles and said that the native beetles don't like cattle dung or where the dung is placed, these results back that up. All right, here's our 9 species of introduced beetles that we caught, and as you can see, the Taurus fulvus, which were those little black and brown beetles in that big catch, were our most abundant species. So quite a significant percentage were Taurus fulvus. Coming in third is bison. So we've got a long way to go with bison. So with the trap results, and here's our native. So with our native species, of that 400 odd, most of them were Australis. Not much else happening. Although the Victoriensis, if you go out in the paddock in sheep dung, you will actually find lots of them. They just don't trap very well. So you need to keep that in mind. Okay, so for each introduced species, we have a map of the results. So the large red dot means that there were over, for this species, bison? Yes, bison. The large red dot is where we had trap catches of 50 or more beetles. The smaller red dot means that we've trapped them, but less than 50 beetles. And then the black dots are trapping sites where we didn't get any bison. So this is a species that we could do much more introductions, which is happening as well. We've also, with the data, made seasonality graphs. So we can see to have maximum dung burial, we need a different range of species to be active at different times of the year. So with the data, we were able to determine for each species when their activity period is. So where you see the spike, what month? May. So in 2009, May was very high bison activity, which is an average across the 48 sites. Also in the result, we had top catches. So from here, we can see that the biggest bison catch we had was 350 beetles in one trap on the 1st of May in Toolangatta Valley. And then there was a nice little bit of competition between farmers to see who had the best trap catches. And you can see from that also that May is the month to catch beetles in 2009. In 2011, that's not the case. All right, so if you would like to look at the maps and the data for each of the introduced species, plus top catches, plus the graphs, seasonality graphs, you can go onto the Landcare Gateway website, and that's in your notes as well. So that's the Dung Beetle Project. Pauline was talking before about the earthworms, and what part of the soil did she say we mainly find them? Yeah, in the top 10, 15 centimetres, in the topsoil. So there's this whole subsoil area where we don't have anything happening. Now, most of the earthworm scientists agree that this longer worm will be a very useful introduction because it operates at depth. So our project was to set up a number of nursery sites. In the past, these worms have just been put out in the paddocks, and that's where it went. They're quite well established in northern Tasmania, but fairly thin on the ground for Victoria. Is that right, Pauline? Yeah. They didn't find any. So, and unlike dung beetles, which you need cattle and dung, earthworms, you just need organic matter. So their application is quite wide. So what is the project? Very quickly, we have set up 8 sites across northeast Victoria. The nursery sites are 5 metres by 2 metres. We rotary hoed up each site. Why would we do that? To scare them. This is before we added the worms. So we cultivated it to try and destroy any worms that were already in the soil. It's sort of there could have been eggs and cocoons. It's not particularly scientific. So then we added 4 inches of sheep dung to the surface. We also added a bit of lime to sweeten it up. And here's our A longer, which came from Tassie, and each site got about 150 worms. Now the idea is to give them 5-star treatment so that they breed up, and then we can put some in the paddock, give some to another farmer to set up a nursery site, and it builds. But to our knowledge, this method hasn't really been done before, so it's a bit of an experiment. So yeah, a trench was dug in the middle. We put in a moisture monitor, so that dot thing, when the dots drop, you know that the moisture is getting lower and the site would be watered. But after the summer that we had, I think our meters maybe dropped 1 dot. It just kept raining. So then we covered the site with geofabric to stop the predators coming in. So this was done in October last year, and we will sample in October this year to see how they've gone. So until then, we don't really know if it's going to be successful or not. But there is an earthworm newsletter. There's some out on the table in the foyer. So if you want to subscribe, October will be the moment. I think we possibly have every earthworm from a 5-kilometre radius in our nursery sites. So why do we want dung beetles and earthworms in our farming system? Because I guess the bottom line is they improve productivity. Now this is a dung beetle trial and pastures that's been done by Dr. Bernard Dobe over in South Australia, and you can see that there's square plots and there's grass growing. So basically there's 3 treatments: dung only, control, and dung plus beetles. So in the original setup, the dung plus beetles had a cage over it. The first one to keep the beetles in, and the second one to keep the beetles out of the dung only ones. Didn't want them flying in. What they then did, similar to John's method, was they then mowed each square. They dried it and they weighed it and they compared the productivity. So they've been doing this for quite a while. So the dung beetles have only been added once, and then they've just been, the results have been measured. Now the kicker is this. In the 7th year, the dung beetle plots have shown a 40% increase in pasture productivity over dung only and the control plots. So every year they've shown an increased productivity. 7 years later, and we're still getting increases. How can this be explained? Now, if you're not familiar with how dung beetles operate, they make holes, and this species goes about 12, 18 inches, maybe even 2 foot into the ground. They then make brood balls, which they bury at the end of their tunnels, and inside the brood ball they lay an egg. So what they're doing is they're creating enormous amounts of tunnels under the dung system. They then, with the brood balls, when the young ones hatch out and the beetles emerge, there's often quite a lot of dung still left in the soil from the remains of the brood ball. So we've got the nutrients from the dung. What other things could explain, and bearing in mind John's talk as well, could explain these increases to pasture productivity after 7 years, or continued increased pasture productivity? And we don't know. This was last year's results. We don't know how long this is going to keep going for. Now, the answer is we don't really know. We don't know why this system is working so well after 7 years of one application, one thing happening. But as Gwyn did say as well about the earthworms, Bernard's research has found that dung beetles and earthworms work really well together. The dung beetles bring down food source, and they've found that with the tunnels there's more earthworms. The earthworms are fatter, heavier, more mass, and the earthworms are also operating at greater depth, So they're following the tunnels down and going out of their normal range. One thing that we have found, these are photos done by Chips, and you can see the black and the tunnels. Some of that black is dung. Sometimes the beetles pack their tunnels with dung when the newly emerged beetle then has a food source and eats its way out. Different species do different things. That's oh, here we go, a little bit closer. So you can see the beginnings of the roots coming down. Now this is 2 to 3 years down the track. So what are we seeing here? Fungi happening there. I think there's another slide of that as well. And this is happening at quite a depth in the subsoil where normally there's not a lot of things happening. So between Chips and the goodwill of Pauline Mealy, samples were sent down because we thought, wow, what's all this stuff? Is it good or bad, or what's going on in these tunnel systems? And what did we find? Okay, so how do I say that? Trichoderma or trichoderma? So this is a bit of a first. I don't think anyone has ever looked at what happens down dung beetle tunnels 2 to 3 years down the track. So Pauline was able to grow some of the species and has told us that they are both very beneficial species to be having. We don't know exactly which one they are, but they're both good. Very good. So why are these important? The fungi can form, we've heard other people talk about it, associations with plant roots in the surrounding soil. As the fungi grows, it enhances the decaying of organic matter, it improves the availability of minerals, and captures nutrients such as phosphorus and other tightly bound nutrients and makes them available to plants. So perhaps this is one of the things that is happening in the soil that could explain why after 7 years the dung beetle plots are still out-competing the other two, the dung only and the control. So we think that's pretty exciting stuff. I guess as a farmer, I don't really need to know how it's happening as long as it happens. So we'll leave that to the others to figure out. So what we do know is that deep tunnelling dung beetles and earthworms are pioneer species and that they make long-term beneficial changes to the subsoil. So these tunnels, aeration, water coming in, nutrients happening, fungi getting stimulated, microbes, I would imagine, starting to cook. Andrew said this morning they need, what was it? Air, food, water, comfort. So the tunnel systems provide air, they provide for the water to come down, and they provide food. I don't know how much comfort though. Well, hopefully good. And these results change the properties of the soil. Healthier soils, improved productivity, and in a sustainable manner as well. So they're great for your farming system. Now in your bags, there is a dung beetle resource DVD and CD. If you want to know why dung beetles are important, because I haven't really covered that, you can watch a classic 1972 CSIRO, almost the same. And why dung beetles were brought into Australia, and also there's a couple of other videos. On the CD, if you go to the how-to guide, there's some information on how to look after your dung beetles.